It's Coach Johnson. We're live. Chapter 1, Unit 1 test. We're ready to go. I hope you're ready to go. It's not the only goal I can dunk on, but hey, that's why we have it in my office. Hope you're having a great day today. If I make this, oh, never done that before. Come on. Oh, look at that. First time for everything. We're having a wonderful day today. Well, welcome to the jungle. Coming on. Got some math going on. I mean, this is what I'm talking about. So, yeah, we're about ready to get some math going on. Got my coffee. Let's get it going. Nothing gets me more psyched than some math on a Tuesday night. What you say? Let's get this going. Hey, we'll turn that off. I'm sorry. Apologize for all the antics there. Hey, shout out to the Sweden followers. I have to always say that because there are some followers over there in Sweden. Hope you're enjoying the podcast. And yes, I am very similar to Jimmy Fallon. So that's what they say over there. You could call me whatever you want, but we're ready to get this thing underway. We got 6 viewers right now. Wow, 6 viewers. The time is now, y'all. The time is now. Hey, just so this is a little bit different. Some of you are going to maybe text in some questions. In fact, right now, let's see if I've got any questions real quick on here. Don't have any on here, but I think what we're going to do is use the YouTube live chat. I'm actually going to pull that up here in a second on my right side and hopefully address those questions. If I miss one, I apologize because I am going to be looking at my screen, not at that the whole time. So if for some reason I missed one, please let me know. Talk about concepts. All right, you can ask any questions on concepts. You can ask any questions on, hey, coach, I want number such and such. You ask, I will do. That's just kind of how we do it in this place. And oh, there we go, a little spotlight action. And we will get this underway. Are you ready? Are you ready for some math? Here we go. We're going to get it going. First problem. Well, I'm not sure. We're going to actually pull this up here. Let's make sure that's there. Make sure someone texts me if for some reason there are any issues that are there. Okay. All right. Will you be working from the review? Yeah, I'm going straight off the review. So if you've got questions, throw those out there. Right on to the right of that live chat there. That's what we're looking at. That's what I'm looking at. So if you could do that, that'd be great. We'll look at those on that. And we got a little shout outs here. If you want a little shout out, put your name there. And I know got Cam in the house, Kevin in the house. Got a lot of people in the house today. But throw a little comment right here. So oh, man, yeah, that's Duncan on that side. So right now I know it's coming a little bit late, but throw those comments out. Would love to touch base with them. Let's start with an identity. How about that? I love identities. Those are always beautiful. All right, so let's take a look at that. Howdy, Scott. Good to see you, dude. Nicole, a little shout out to Nicole. She's always faithful on these podcasts. I mean, it wouldn't be a podcast unless Nicole was showing up. You know what I mean? Just one of those things. All right, so let's go straight to an identity. These are just ones that we'll start with. I figure someone has a question on it. Again, I can see the live chat on my feed right now. Feel free to throw a problem out there and we'll address it, okay? One of the areas that I'm a little concerned with is just the identities, and it's not because of this group or anything. It's just probably the number one thing that people struggle with when it comes to this test. The good news is that there's not going to be anything that's going to really take you back. I'm not going to try to trick you on this. So if you can just kind of follow through with, okay, this is the process and getting from point A to point B, you'll be G to G, good to go. So let's start with the one on the top right. Tangent squared plus 1 over secant equals secant there. One of the things that I like to address in terms of an identity is I always like to see first off, yeah, and a lot of people are like, well, coach, what about sine and cosine? And you would be right. That would be a way that we could do it. But maybe an easier way is anytime I see something that's squared, I'm just going to think in the back of my mind, can I simplify something with tangent squared to be able to break that down? So like, for instance, on your formula sheet, tangent squared plus 1 produces a value of secant squared. Okay, so we're going to do secant squared of, I think it's this weird symbol, but either way, you could just use theta or something. But secant squared is tangent squared Also, with these identities, it's very important that you not only know how to use those identities and plug them in, but maybe even to switch it around. So throw those, again, out there, plug them in, and then we'll go from there. So you got secant squared on top. You've got secant on the bottom. I'll just use theta because we know that. Secant squared on the top with secant on the bottom. We know that we could take one secant out, which produces one secant on the top. So when doing this, I'll be left with secant of theta. And we know that that equals my right side. So we just want to write one more time. Secant of theta equals secant theta. Okay? And again, that's just writing that down. And someone asked me, hey, Coach, what's the answer? Is this the answer? Well, we know that this is going to be true, correct? The answer is really from point A all the way to point B. And it's really what we call a proof that you're trying to verify that the identity is really true. Okay? All right. All right, let's keep going. Right now, got 10 viewers. Oh, my goodness. This could be a record. Never have had more than 5, really. I lie. I've had more than 5 before, but this is quite a few. I appreciate y'all for showing up. Let's do this one right here. We've done this one right there on that side. Let's go to the one that's kind of in the middle here. Again, this one is one, if you're not careful, it could really get you. Again, I could convert this to sine and cosine, but I recognize that may not necessarily get me to, it might not simplify it very well. But what we can do is this. We could say sine squared plus cosine squared, right? And I can rearrange this. Because it's a plus sign, it doesn't matter what order that we're in. We've got sine squared plus cosine squared. And when we do that, that value right here, this identity, when it's sine squared plus cosine squared, would be 1. So you'd be left with 1 plus, and then we left with tangent squared theta. Okay? Now we keep this right side the same, okay? We keep it all by itself, okay? All right, reminds me of a song. All by myself, don't want to be. I'm telling you, I get crazy at night. I'm telling you, all right? Sorry. So what we've got now is 1 plus tangent squared on the left side. Is there an identity that simplifies? And we remember that, yes, there is. This produces a value of secant squared theta. And we just put a little bit of a secant squared theta on the right side, knowing that we did, in fact, get to that answer. Okay? All right. Yes, third period showing out. Little holla out to third period. Nicely done there. Very good. So one other one. I want to do this one. I'm trying to think of one that might be a good one. Okay, how about this? Cosecant squared theta. I'm just trying to think. Plus, and I'm trying to think what would be good. Let's just do this. Let's go backtrack a little bit. All I want to give to you, there will be one that's on the test where I might give something like this, and the identity would be yada, 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 okay? The reason why I want to go over this one with you is because Nicole, a little shout out there. Again, a little shout out for Nicole there. So with 1 over sine and 1 over cosine, we can get a common denominator. So anytime that I get to a point where I add 2 fractions, get a common denominator. So I'll put a cosine of theta here. What I do to the bottom, I've got to give some loving to the top. So we're going to do that. With the same thing over here, if I do it to the top side, I also do it to the bottom. So this produces cosine theta plus sine theta all over cosine theta sine theta. Okay? All right, so again, these right here, I don't know what this would be equal to. I'm not saying that this is the exact one, but I remember that there is one with 2 fractions on it. Okay? Okay, someone just gave it to me. Yes, you get all the identities on the test and the unit circle, but remember that you can also, with the unit circle, I'm going to roll the dice, and the first thing you got to do is actually write out whatever quadrant it rolls to, okay? It should be easy, should not be tough, but a lot of times people will mess up on things like that that could get them some easy points. So just look over the unit circle. I'm not doing it to nail y'all. Once you turn that in, that's part 1. This part 2 will actually be the test, and then when I give you the test, you'll have the actual unit circle on there, okay? Someone said, could you do the top one, which was a great question. We have right now 1 plus cosine of theta and 1 minus cosine of theta. And in this situation, anytime that I have back-to-back, so something like this, something like this, let's see, I think there was another one over here. This one's a good example. Anytime I have back-to-back, a good strategy might be to actually distribute each of these here, if that makes sense. So like 1 times 1 produces 1. 1 times negative cosine is negative cosine of theta. Cosine theta times 1 is positive cosine theta. Cosine theta times negative cosine theta is negative cosine squared theta. Okay? Now, once I distribute that, I could cancel out the plus and minus, leaving me with the value of 1 minus cosine squared theta. Now, with these ones, it's a little bit easier because we know that we're going to get to sine squared. So a lot of you could probably be smart enough to say, oh, yeah, that's sine squared theta. Therefore, sine squared theta equals what's on the other side, right? Okay, and we could check that off. However, if you don't remember that that's true, go to your identity, which is sine squared plus cosine squared equals 1. And we're going to subtract cosine squared right there. Take it to the other side, and sine squared equals 1 minus cosine squared. And that's how I changed the identity to know how I can plug it in for that there. These ones are a little bit easier when it comes to when you have both sides. The ones that may be a little bit tougher are when you have to actually exchange the top ones around, right? So like tangent squared plus 1 is easy. That's secant squared, right? Secant squared x. This one, distribute. A lot of these are a little bit easier. There is one. Okay, I want you to think about this, okay? So this is I believe there's one like this on the test, all right? So just kind of giving you a heads up. What if I said, what is -1, or how about this, sine squared x minus 1? What is that equal to? Now, if this is the identity, right, and I give you this down below, okay? So that right there is the problem. What can I do to match it up? Well, let's do this. Let's get sine squared to the other side. So we're going to subtract sine squared, right? Do that to both sides. So we're left with cosine squared of x equals 1 minus sine squared x. So question, I want you, I don't care if people look at you weird, just like Dora the Explorer, I want you to answer in your house, okay? Right now. Doesn't matter who's there. Yes, you, everybody, okay? How can I get from this to where I have a positive sign and a -1? Notice they're opposites of each other. I want you to yell it right now. Go. I'm waiting. Very good. Nicely done. So what you would do here is with the 1 and with the negative sign, if I put a negative here, I will also put a negative with 1 and change the negative sine squared to positive. So negative cosine squared is what is equal to sine squared minus 1. Just be very careful on the signs, especially with those ones. It can be a little bit tricky on those there, okay? All right. We're going through a lot of problems. You are not bothering me if you throw out a problem. Just throw the number down on the left side. Right now we have approximately 13 viewers. Good night. I'm going to cry. I'm literally going to cry right now. This is life-changing. Oh, man. And they're not all from Sweden. This is incredible. Okay. Thank you for showing up. So I do want to do a couple of these other ones. So, again, if you see one that you're like, on, just let me know. The ones that should be pretty good is ones like this where I say, change the color from white there, 7 pi over 6. So like 7 pi over 6, I would start at 0, and it would be in quadrant 3. You should be good on that, right? The point at which 7 pi over 6 exists would end up being negative square root of 3 over 2, comma, negative 1/2. And you would just plug that in. Now, if I said find all the identities, that's where you go into sine, cosine, tangent, cotangent, cosecant, and secant, okay? So again, that's a good one as well. Kendall, I will do that reference angle one in just a second, okay? We'll definitely do that. Check out this one, negative 13 pi over 5, coterminal, right? Now, just to remind ourselves, right, we've done this like a bazillion times, right? But if we are, if we're doing this, right, and I'm looking at you, right? Oh, man, here we go. I'm looking at you on an angle, negative 13 pi over 5. If I find a coterminal angle, what am I going to do? I'm going to do this. Just like that. 360 dunk on your head. All right? Not you, but whoever's there. So with that, we've got to add or subtract 360 or 2 pi. I've never done that before. That was pretty cool. So what we would do is just add or subtract, right, to get that coterminal angle. Remember, reference angle is a little bit different. If I have a reference angle, I don't add or subtract 360 or 2 pi. That's coterminal, right, what I just did. Reference angle asks 2 questions. Where's the closest x-axis? How far is it away? And we're going to do a couple of those in just a second right after this, okay? I just wanted to give you all that treat of watching me dunk there. It doesn't happen often. Oh, there's the comments. Oh, look at that right there. Nobody post anything bad there right now. We'll take that off. There we go. Okay. Let's go back to this. Okay. So negative 13 pi over 5. Okay. Let's see here. Boom. Pull this up here. Excellent. Okay. So abs is that 10 feet. Very funny. Very funny. All right. So I'm going to add 2 pi to this negative 13 pi over 5 to find that coterminal angle. Notice that it has to be given in degrees or radians. A lot of times if I give it to you in radians, I want it in radians. It's usually how it works there. But we want a common denominator. So if we put a 5 on the bottom, this is the part we miss. We've got to multiply the top by 5 as well. So that produces 10 pi over 5. Now once I do that, I get negative 3 pi over 5, which even though I added 2 pi here, it still does not quite get me to the positive value I was looking for. So if it's pretty simple. If I get to this part and I still have a negative value, just add 10 pi over 5 again. And when I do that, it produces a value of 7 pi over 5. So 1, 2, 3, all 3 of those are coterminal angles, okay? All right. Awesome. All right, so oh my goodness. I just saw the feed there. Glad it's not up. Yeah, number 5. Yeah, we haven't done number 5 there for sure. Let me go to the reference angles first. Let me do this. Some of these are from class. I'm sorry. Thought I had erased those. Okay. Boom, boom. Terminal. Okay, we've done that. Oh, reference angle. Here we go. 13. Number 13. Okay. And oh, by the way, I would also, if I were you, this is just me, I would find the reference angles of these as well. I'm sorry, not that one. Where are you? Where are you? There you are, right here. I would also, with these 3, find the reference angles. You don't have to, but it's just an extra practice there. So feel free, let me know. Remember that the symbol for our gangsta sign, remember gangsta, not gangster, is of theta with this sign on it. That means reference angle. Okay, reference angle. So the first thing we want to do in determining, it says find the reference angle for a given angle in degrees and radians. So be careful, underline that, right? We want it for both. So in doing this, negative 321, we want to find this reference angle. So we know that positive 321 would be just shy of 360, but negative goes back, right about in there. Okay, so it does produce a value that's in my first quadrant because of the negative. Okay, remember negative means it goes clockwise. Now the question is, what is the closest x-axis? Is it on my left or on my right? And my answer is that right there. Now, one of the things we started struggling with today in class when I talked about this is when I have negative 321, if the closest x-axis is right there and that's the value I'm trying to look for, that is my reference angle, right? Do what makes sense. If 360 is the whole and I come to 321, I know that reference angles are always positive, so I can simply take 360 degrees, subtract the full angle of 321, producing me a value of 39 degrees. And so 39 degrees would be my reference angle. Now to convert that into from degrees to radians, we're going to multiply by pi over 180. And when I do that, I can reduce this. And if it says in terms of pi, ask me tomorrow, because I guess I could take either a decimal or reduce, but we'll do reduce just so we know. Divide this by 3 to get 13. Divide it by 3 to get 60. So I end up getting 13 pi over 60 as my answer. So this is in terms of radians and degrees, okay? Awesome. Yeah, we'll do 5 and 14. I'm coming right on down. Let's do 6 pi over 7. 6 pi over 7 is just shy of pi, right? Think about it. If you have 6/7 of this pi distance to here, it's going to be just shy of that pi there, right? So 6/7 is just shy there. The question, what's the closest x-axis? Right here, how far is it away? And so this right here is my reference angle, right here. I note that pi is the total distance here. So pi minus 6 pi over 7 will get me what is that red angle right here. So what do I do to subtract? I get a common denominator, so I'll put a 7 on the bottom. What I do to the bottom, I do to the top. When I subtract that, I'm left with pi on the top and 7 on the bottom. And then I'll multiply by 180 over pi to get what it is in radians, okay? All right, and then I'd go from there. I'm sorry, to get from radians to degrees, okay? All right, so that's reference angles. Nicely done. I know you're focused. I can see you. Some of you, I was telling some people in a class, I'm not going to mention who it was, but I did mention to them that I could see through their screen, and they may have believed me. They may be watching right now, so I don't want to embarrass them. But they did think that I could actually see them through their screen. So if that's if that was y'all, I'm sorry I messed with y'all tonight or today. I apologize. Apologize for that. All right, number 5. Number 5 there. Number 5 states that we are in quadrant 4. Now, please draw the triangle right. If you don't, I will haunt you. Okay, I will literally haunt you. Please do not. Please draw it out. It's in the 4th quadrant and up, right? So it's connected always to my x-axis, with theta being connected to the origin, right? My 90-degree right there, okay? So we know it's in quadrant 4, and we know we're given this right here, correct? Now, what we want to do is get y equals mx plus b, okay? The reason why is that will allow me to see what my rise over run is. So I'll add 3x to both sides, add 3x to both sides, leaving me with negative 2y equals 3x. I'll divide by negative 2, divide by negative 2. So y equals negative 3/2 x, right? Right there. Now remember that because it's 3/2, we know this is my rise here and my run on the bottom. So I'm rising the value that's over here, negative 3, right? Because that's up and down here. Running is 2. So 2 is left and right. So that's going to be right here. So what we're going to do is we're going to find what the c is by doing my Pythagorean theorem. So 2 squared plus negative 3 squared. Be sure that when I do this, negative 3 squared is always positive. Okay, that's huge. And that equals c squared. Okay, so what we would have is 4 plus 9 equals c squared. So 4 plus 9 equals c squared. Or 13 equals c squared. Square root, we get the square root of 13 as our h, okay? I'll kind of put that right there. That's a square root of 13, okay? Now, why is it positive? I want you to yell out right now. Why is it positive? All of you, all 14 of you right now. I think, is there 14 right now? 16, wow, we are getting up there. This is really exciting. This is epic. Because it's the hypotenuse, it will always be positive, right? So just remember that when we find what sine of theta is, right, we think SOHCAHTOA, right, our friend, SOHCAHTOA. And we remember that with SOHCAHTOA, we have opposite over hypotenuse. So my opposite's negative 3, and my hypotenuse is square root of 13. But we don't like a square root on the bottom, right? It's like kissing your sister. We don't want that. So we're going to multiply top and bottom by the square root of 13. So we're left with negative 3 root 13 all over 13. And that would be what sine would be equal to. If you want me to come back to this, I will, but you would then go to ka, toa, and then remember that once I do that, I then can go back to cosecant, secant, and cotangent to figure out the other identities as well, okay? All right. Any questions on that? Throw them out there. Cam asked the question before I get to 14, do you want our radians in pi radians, or is it okay if we do the decimals? Okay, it's a great question. Tomorrow I will no, I'm gonna look at the test right now. I'm gonna look at it right now and tell you. I believe that in some cases I want it in terms of radians as a decimal. and sometimes I want it in terms of one in terms of pi. Let me see here. Okay, so some of these are like, hey, where is the quadrant? Where's the quadrant in? I'm trying to think of also some ones too. Oh, I need to go over that. Yes, I do. Okay, I need to go over those. Okay, so if I give the, I want to make sure before I say that. Okay, so I was just checking on it. Consistently, the only time that you will keep the radians, so every time you're going to keep it in terms of pi, every time. The only time you will not is when you do the S over R equals theta. Is that cool? Okay, S over R equals theta. Oh, you want me to put up the test on the camera, on the camera there? So oh, that's what you want there? Is that what you want? Okay, I can't do that, but what I can do is give you in on a little secret. Can I do that? So right now, before I go to 14, do not, can we see it? Can we see it? If we average a 90 on the test, can you post your football highlight film? Hey, I played football in high school. I played quarterback. Y'all will never believe me on this. You won't ever believe me, but it's true. But let me give you a quick, oh yeah, let's do this. Let me give you some stuff, okay? All right. Here's the thing. Number 12 is huge. Okay? In fact, could we camp right here? I'm going to camp right here for just a second, okay? There's a couple of them on here that say sine of pi over 2 minus theta, and what does that equal? Okay? What is secant of pi over 2 minus theta? What does that equal to, right? What is sine of negative theta equal to, okay? All of these, I'm telling you right now, these are on the test. I'm giving you all of them right now. What is cosine of negative theta? What is that equal to, right? And I'm going to do that all based on number 12. Sound good? Please, please tune into this one. If there was any problem that you need to focus in on, it's this one. Because there's just not that many of them on the review sheet, but it will show up consistently throughout, okay? And if you remind me tomorrow, I can also put that down as well, okay? Now, here's the kicker, okay? Here's the kicker. In all of these, okay, in all of these, and this is, again, a hint that because, again, you are here, I'm giving this to you. In number 12, I'm going to use number 12, the fact that cosine of theta equals 15 over 17 to answer each of these questions, okay? Is that cool? All four of these. Every one of these, okay? Here's the thing, though. In order to do this, I want to first, before I go here, I want to first tell myself what this is equal to. I am jibby jacked right here. I'm jibby jacked. So each of these are on the identity sheet. They are on the identity sheet. This one does say, I think, 90 minus theta, but it's the same thing. So I'll recognize that on the review sheet. Same thing. This is secant of pi over 2 minus theta. Same thing. Oh, I'm sorry, 90 minus theta. Same exact thing. So watch this. What we're going to do is before we do anything with the above right here, I'm going to say what these are equal to. So on the formula sheet, this is not hard. We're just going straight to the formula sheet. We know this is equal to cosine theta. We know that this one is equal to cosecant of theta. Okay? Sine of negative theta produces negative sine theta. Okay? And cosine negative theta produces cosine of theta. Okay? Check me on that. Make sure if there's an issue on that, let me know. But because I'm doing it by memory, but I'm pretty sure that that's true. You don't need it by memory. You just need to make sure you know how to apply it. So with that being said, I would first start off, if I gave you any of these, write each of these out. Got me? Write each of them out. And oh, by the way, let me just throw another one out there just in case. Let's put secant of negative theta. Got me? That is also equal to, this is equal to secant of theta. Again, all these are on the formula sheet. So everything to the right of the equal sign is what I'm focused in on, okay? All right? Making sure if there are any questions. Oh, third period, everyone's here. Shout out in the hizzy. Get going. This is Phi. We're finessing all day, all night. That's right. Nicely done, y'all. Great job. Can't believe I just said that on a podcast. All right, so let's just keep going. What we're going to do now is before I answer 1, 2, 3, 4, 5, okay? Before I answer 1, 2, 3, 4, and 5, let's create the triangle. Note, okay, this triangle, cosine of theta equals 15 over 17. That sets up my triangle there, okay? All right, so this is my triangle. Remember that this is adjacent over hypotenuse, okay? Notice I have not looked at any of these because if I do, I will confuse myself, okay? I will. But what I can do is just create a triangle because I don't know what quadrant it's in, and I don't care. If it doesn't tell me, we know we won't care on that, okay? So if this is theta right here, we will then find 15 over 17 or the adjacent over the hypotenuse. So this is 15 and the hypotenuse is 17. Now the idea of this is to find what the opposite side is so that I can find all the other values such as sine and all that other stuff. So what I'm going to do is I'm going to do Pythagorean theorem, which would be 17 squared equals 15 squared plus x squared. We'll just put x here, okay? And when I find that and I subtract and do all that jazz, I get 8 as my opposite side, okay? All right, hold up. All right, we're lost, right? Okay, so help me on this, okay? Help me on this. I want to make sure I go through this. What is given, okay? I'm going to highlight this because I know this is different, okay? I know this is different. Hardest one on the test because there's not a whole lot on the review sheet like this. Okay, notice. Okay, great question. And Trey, tell me what you're confused on when just put it in that sidebar, okay? Because I know this is tough. You're not the only ones lost here, I'm sure. Okay. First off, let's go through this, okay? These two right here, 1 and 2, I'm going to treat as if they are separate. What do I mean by that? I mean that with this part on the inside over here, I am going to literally do that separate from everything else on top. Notice, have I touched base on any of these values over here? No. What would I ask on a test? Well, the even and odd identities are here, here, and here. Now, these two right here, we call them cofunction identities. You don't need to know that. All you need to know is that if I were to ask 1, 2, 3, 4, and 5, I would literally plug in what is the formula, okay? So the formula, what is given is this part, this part, this part, this part, and this part. Now, what you're confused on maybe is the fact that I only asked for sine of negative theta up here. And you would be correct. I am doing all the rest of the ones that are highlighted just to expose you, okay? Not that I'm trying to expose is such a weird word because I can't use that. I'm trying to give you some I can't say that either. I want to try to give you some information to help you with this, okay? I'm not trying to like nail you. So this one, this one, this one, this one, and this one, if I were to ask any of those, the first thing I do without looking at the problem is I write down the formula. What is it equal to? Well, it's equal to, again, I'm coming here. It's going to be equal to this. This one's equal to this. This one's equal to this, this, and this based on what is on the formula sheet. Okay? Are we good so far? I will give you the formula. Perfect. And oh, by the way, all of these 1, 2, 3, 4, and 5 are not related. Okay, I didn't put those on number 12. I'm just taking it a little bit deeper to help you with ones that are on the test. Does that make sense? Okay. So again, coming back to it, if I just asked number 12, the only thing you would have to do is sine of negative theta, which would be this one, right? That's all I would have to focus on. But I gave you 1, 2, 3, and 4 because I just want to give you a little bit of help on those on the test, okay? Trey, are you good on that? Yes, Nicole, or Kendall, good. Okay, so coming back to it, these right here this is going to link back to all of these identities. Remember, the ones I'm looking for are to the right of the equal sign, right? So what do I mean by that? Well, let's talk about now the ones that are highlighted. Since we already put what it's equal to, we actually can ignore that left side. All I'm trying to find now, because I said this, all I'm trying to find on this one is cosine of theta. So what is cosine of theta? Well, it was already given to us, right? So it's actually 15 over 17. So 15 over 17 actually replaces cosine of theta. Got me? It plugs in for it. It substitutes in for it, okay? All right, look at this one. Cosine of negative theta equals cosine theta. Again, just because I gave it to you, okay, it's easy on this one. Since we already know it, we just plug in 15 over 17. And this replaces what cosine of theta is. Notice, I write the formula first. That's huge. Write the formula first. The next thing I look at is if I know what cosine of theta is, I can find secant by doing the flip-de-flip, right? And doing, when I flip it, 17 over 15. So 17 over 15 equals, and I don't have enough room, but equals secant of theta, right? So what is this? Well, we substitute in, and now we plug in, and we recognize that 17 over 15, that's what is equal to the other side, okay? Because we just plugged in. That's why we write the formula first, okay? All right, Kendall, what were you saying? I don't know if I've done 3 yet, but I can get to it. I think I've got another one. I think it's 14 that I'll do in a second. Wow, this is very colorful, by the way. Very colorful, man. This is just beautiful. All right, so look at sine. Now, the sine you have to actually find, because sine we know is opposite over hypotenuse. So would you agree that sine of theta is opposite, which is 8, over hypotenuse, which is 17, right? No sign changes in terms of like plus or minus, because all of them are positive, because they did not give us what quadrant it was in. So we just simply take this, 8 over 17, plug it in for sine of theta, and what we end up getting is 8 over 17, and then we just bring the negative up, right? Because the negative changes, so this whole value is negative 8 over 17, okay? All right, perfect. Yeah, this is art right here. This is absolute craziness, but it looks so good. What color have we not used yet? Red. We haven't used red, so let's use red. This is awesome. I love podcasts. Okay, so cosecant. If sine of theta is 8 over 17, cosecant is the reciprocal of sine, right? So if sine is 8 over 17, cosecant of theta is 17 over 8, right? Because you just flip it there. So literally you just plug, if that's true, 17 over 8 gets plugged in. And again, see how easy that is? It is easy if you write out the formula first and have the triangle off to the side, and then use the triangle to then see what I plug into, or what I need to plug into on the right side. That's why we plug in. That's why we label it there, okay? All right. Oh, I'm sorry. Red is clashing. All right. Very cool. Yeah, that's right. Oh, Chris is okay. There's a little bit of a feud on here. My apology on that. Starting to get really lit right now. Really lit. All right. All right. So perfect. Okay. So let's. Oh man. Okay. 14. I think this one was the one, Kendall. Correct me if I'm wrong. This one states very similar to the last one. 15 over 17. Hold on. Was that the same thing? Yeah, it was literally, we literally did the same problem, didn't we? Again, number 14, here's theta, here's the 90 degree, adjacent, remember, means that I'm like right next to it. I'm hugging that thing. Remember, y'all always made fun of me for that. Feel very self-conscious about that part. We have 15, 17, and 8, okay? We're Gucci there. This is opposite, hypotenuse, and adjacent, right? So the question is what is cosecant, okay? What is secant? And what is cotangent, right? Well, again, just like we did before, if we can find what sine, cosine, and tangent are, and then just do the reciprocal of that, we'll be G to G, good to go, okay? So cosine is 15 over 17. Sine is 8 over 17 because it's opposite over hypotenuse. Tangent's opposite over adjacent, so 8 over 15. And then just do the reciprocal. So we got 15 over 8. Secant is 17 over 15. And cosecant is 17 over 8. Remember, C and S go together. That's something, too, to remember. And then go from there. Also, remember SOHCAHTOA. That's huge. You got to memorize that. You got to know that sines with X, cosine Y. Sines with Y, cosine X, tangents Y over X. You need to also know S over R equals theta. Remember that theta is the, in terms of radians as a decimal. Be sure of that. So if I give you 2 in degrees, don't do that. Make sure you plug it in and go from there, okay? Oh, someone wants me to kick someone out. Is that Chris? Okay. Yeah. If everybody puts down they want Chris out, we'll start talking about it. Okay. All right. Oh, there's a feud going on. So am I okay? Oh man. Oh man. Oh, so a junior's calling out a senior. Wow. Okay. Well, Chris just said go blue, so he's in. He's completely in. I'm wearing got my Michigan stuff I had on, all that. Yeah, he's in. He's still in. Okay. Petition. All right, kick him out. Oh wow. This is getting intense. Okay. I sure hope my Sweden followers are following this. This is good stuff. This is very entertaining. Very entertaining there. I kind of lost which one which one we were doing next because I was going through the conundrum up here using y'all's word right there. Okay, 5 is it? Did I do 5 already? Did I do 3? 3 I think I already did. I addressed that one. Man, we've done this. I think we did this one in class right here. Right, we did this one. Okay, this one right here is a big one too. I get a lot. Let me give you another one because I think we did this one in class. I want you to do secant of theta equals, give me a good one, 2 squared of 3. 2 squared of 3 over 3, okay? Now, if this is true right here, and I say find 2 areas where it's in degrees and radians where this is true, I'm going to flip secant to cosine, right? So cosine of theta equals, we're going to flip this, 3 over 2 root 3, okay? Now, once I get to this point, hopefully this works, I'm going to multiply top and bottom by square root of 3 to where I get 3 root 3 all over 2 times square root of 9. Now, we're just taking this further, okay? We're just flipping it. This is the similar problem to what's up here, all right? We'll get a little Michigan colors here. So we go square root of 9 is 3. Okay, so this is 3. 3 times 2 is 6. So we got 3 root 3 all over 6. So 3 goes into 6 twice, giving me square root of 3 over 2. So the question is, and I know that was a lot of work there. The question is what? Where's cosine square root of 3 over 2? Okay. Oh, yes. Okay. Thomas, a little shout out there. Little shout out on that side. Seniors, we're going from there. Seniority. Oh man, this is good night, Chris. Someone said, "Wow, this is intense." Everyone's gaining up on Chris. This is intense here. I don't know how to take this. I know that's why I said Thomas. On your thing it says Thomas, and he said, "Yeah, I knew it was coming. I knew it was coming." I was like, "Oh my goodness." Oh, there you go. That's Thomas right over there, right? We got Thomas coming on here on this side. That's why I laughed. That was pretty good. All right, so where is cosine going to be square root of 3 over 2? We're having too much fun. Where is cosine square root of 3 over 2? Well, what I could do is I could actually see where on my unit circle is cosine going to be square root of 3 over 2. Well, I know it's at 2 spots, right? But what I got a lot of the answers is 30 degrees or pi over 6, okay? 30 degrees or pi over 6. So that's our first set of answers. That's the one that most people get. But what people don't realize is we want 2 sets of answers. It says 2 solutions, so yeah, I see where you're coming from. But this would be the first one, right? And we would also get another one. Where's cosine also square root of 3 over 2? Thomas, what do you think? I'm sorry, that's me. I'm sorry. Ford, what do you think? Yeah, I think you're right. I hear you all the way through. So I think it's at 330 degrees or at 11 pi over 6. Okay, you'll have the unit circle, so it's the application of it. But don't forget to put both answers down, okay? All right. Ford, forgive me. I'm sorry, dude. I was just messing with you. Sorry about that. Man, this is getting real. This is getting real right now. I've never had a feud or feuds like this, and I haven't even heard from Chris in a little while. I'm hoping he hasn't left because of y'all running him off. That would be That'd be pretty bad there. But 16 are still watching. Gotta love it. Any last minute questions? Any last minute questions there? Throw them out there. I'll kind of hold off for just a second. Wow, everyone's gaining up on Chris. This is bad. Oh, you're here, so okay, I got you. Chris isn't backing down. Ford hasn't responded, so hopefully he hasn't defriended me or something like that. I hope all is well on that. Sorry, Ford. I had to help with that. Y'all, do you know that I have never done this before? Well, maybe I haven't done all of them. Let me see this. I don't think I've done these ones up here. Actually, 10 and 11 I haven't done, but I've never done this many problems on a podcast. This is pretty good. So thank you so much for all that y'all did there. Appreciate your help. And just appreciate y'all for doing it, hanging in there. Chris, it's your bedtime. Wow. If you're following these comments, the comments are worth the study session. And I can only imagine that this is going to go, this is not going to stop anytime soon between podcasts there. So, again, if you have any questions at all, throw them out there. But I think I'm going to check out here. What we'll do is tomorrow morning, 7:15, if you want to show up, then come on. Mary, yours team won. So, yeah, y'all have donuts tomorrow. So congratulations. Holla out to all y'all in the hood. Give you some, all that. Yeah. Hope you have a great night. And, man, appreciate y'all. Appreciate y'all. Shout outs. I want to give some shout outs to some people. Ford, Mary, Nicole, Trey, Chris, Kendall, Jared. And I'm going to miss some names. But some more shout outs. Senor got you. I've got, did I say Nicole, I think. Scott is in the house. Got Scott in the house. And appreciate y'all. Hey, have a great night. I will post this podcast right now on the top. We'll see you later. Bye.